Hello friends, today we are going to begin our journey into the world of physics with a foundational topic, units and measurements. Understanding this topic is critical. It is the language of science and the basis of all physical calculations. What is a unit? A unit is a standard quantity used to express a physical quantity. It gives meaning to measurements. For example, when we say someone is 170 tall, what does that mean unless we specify centimeters or inches? So, units are essential to provide clarity and consistency in communication and calculations. Types of units. Units can be broadly categorized into two types. Fundamental units. These are the basic units that are not dependent on any other quantity. For example, meter for length, second for time. Derived units. These are formed by combining fundamental units. For instance, velocity is meter per second and force is Newton, which is kilogram meter per second square. Systems of units. Over time, scientists developed various systems of measurement. The main systems are CGS system based on centimeter, gram and second. FPS system used mainly in the British system uses foot, pound and second. MKS system meter, kilogram and second. Today, the globally accepted system is SI system or International System of Units, which builds upon the MKS systems. SI base units. The SI system defines 7 fundamental units, each for a basic physical quantity. Length meter, mass kilogram, time second, electric current ampere, temperature Kelvin, luminous intensity candela, amount of substance mole. These units form the building blocks for all other measurements in science. Practical units in space science. Let us move to a more astronomical context. In space science, distances are incredibly vast. So we use a practical unit called the light year. A light year is a distance light travels in 1 year in a vacuum. Since light moves at a speed of 3 into 10 raised to 8 meter per second. 1 light year is approximately equals 9.46 into 10 raised to 15 meters. It is important to remember this is a unit of distance, not time. Derived quantities and their SI units. Now let us look at commonly used derived physical quantities and their SI units. Force Newton, work or energy Joule, pressure Pascal, power Watt, potential difference Volt, frequency Hertz. Each of these can be derived from combinations of fundamental units. Some additional derived quantities include electric charge Coulomb, resistance Ohm, capacitance Faraday, inductance Henry, magnetic field Tesla, magnetic flux Weber, radioactivity Becquerel. All of these are based on the SI system and help describe various physical phenomena. Conversion of units. Sometimes we need to convert units between different systems, especially from imperial to metric. Here are a few examples. 1 inch equal to 2.54 centimeter. 1 foot equal to 0.30 meter. 1 yard is equal to 0.91 meter. 1 mile is equal to 1.60 kilometer. 1 nautical mile is equal to 1.85 kilometer. Knowing these conversions is especially useful in engineering, aviation, and navigation. Here are more conversions for quantities like mass and power. 1 liter is equal to 1000 centimeter cube. 1 ounce is equal to 28.35 gram. 1 pound is equal to 0.4537 kilogram. 1 horsepower is equal to 746 watt. 1 yard is equal to 3 feet. 1 foot is equal to 12 inches. 1 mile is equal to 5280 feet. Understanding these makes it easier to switch between unit systems. Temperature conversion. We often deal with the temperature scales. To convert from Celsius to Fahrenheit, use the formula F is equal to 9 by 5 into C plus 32 as shown here. For example, 0 degrees Celsius is equal to 32 degree Fahrenheit. 100 degrees Celsius is equal to 212 degree Fahrenheit. Also note, 310 Kelvin is about 37 degrees Celsius, which is roughly normal human body temperature. To summarize, units are essential to measurement and scientific communication. The SI system is globally accepted and based on 7 fundamental units. Derived units are built from these fundamentals. Practical units like light years and proper conversions are vital in real-world applications. Okay, thank you.